Good morning, everyone. My name is Kaijin, and my teammate is Alex Fung. We are come from DFT2 Group 8. Today, we're going to present our assignments for subject AACS2034, which is Fundamentals of Computer Networks. In this presentation, we're going to divide it into 6 parts, which is network scenario, topology diagram, calculation, subnetting table, addressing table, configuration, and pin connectivity. First, we will be looking at network scenario. Me and Alex, as the newly appointed network engineering for New Millennials University, has been tasked for designing and set up a robust local area network infrastructure to cater the needs of the university's diverse departments and faculties. In this university, there are 2 locations, which is location A and location B. There are also several departments in these 2 locations, which is Chancellery, Bursary and Administration Department, Marketing and Student Affairs Department, International and Local Admission Department, Faculty of Information and Technology, Faculty of Business and Language Studies, and also Faculty of Health and Medical Science. In this slide, we can see that location A are 100 meters far away from location B. In location A, on the ground floor, we have Student Affairs Department. On first floor, we have International and Local Admission Department. On the second floor, we have Marketing Department. And for the third floor, we have Chancellery, Bursary and Administration Department. Let's look at location B. We have 3 faculty located on location B, which is Faculty of Information and Technology, Faculty of Business and Language Studies, and also Faculty of Health and Medical Science. Next, we are going to the calculation part. And in this table, here shown the holes required by all of the department as I mentioned just now. And we need to calculate the 5% growth of the holes required by each department. Let us take an example. For location A, Chancellery Department, the required holes is 196. We are going to take 196 times 135%, and we will get 265. This is the holes required after the 35% growth. And the following departments and the holes required will be using the same method to calculate. Now we are looking at the subnetting table. Each color in this table and the row will refer to different department. For Chancellery Department, after calculation, we need 265 number of holes, and we need 512 binary numbers to handle the number of holes required by Chancellery Department. So the maximum holes will be 512 and the minimum holes will be 257. For the network address, we design 10.0.0.0, and the CIDR we are using /23. First usable, which is 10.0.0.1, and for the last usable, we are using 10.0.1.254. And also for the subnet mask, we are using 255.255.254.0. And last, with the broadcast address, we are using 10.0.1.255. And the other departments will be follow the Chancellery Department for the subnetting table. Next, will be addressing table. In our topology diagram, we are using router, switch, and PC only. As we can see, router is using gigabit Ethernet as its interface. For switches, they are using VLAN 1 as the interface. And for PC, we are using NIC. Let's take a look on the router. For the router with gigabit Ethernet 1/0 interface, we assign the first usable address, which is 10.0.0.1, and the subnet mask will be all the same, which is 255.255.254.0, and there are no default gateway for router. In switch, for example, we are looking at chancellery switch. We are using VLAN 1 as the interface, and we will be assigned 10.0.0.2 for its IP address, and also 255.255.254.0 as the subnet mask. And for the default gateway, we are using the first usable, which is 10.0.0.1, as same as the router of gigabit Ethernet 1/0. We are using the same. Now, let's take an example on the PC. For PC0 and PC1 and also PC2, which are located on chancellery department. So we assign 10.0.1.254, 10.0.1.253, and also 10.0.1.252 for the IP address of the PC. And the subnet mask will be the same, 255.255.254.0, and the default gateway will be also using the first usable address, which is 10.0.0.1, and so on. And this shows our network topology. Thank you. That's all for my part. I will pass to my teammates Alex.
Our network topology design consists of two locations, A and B. Each department has three PC connected to a single switch. However, the second floor and the ground floor share a switch for the connectivity. The distance between location A and B is 100 meters. So, we utilize the copper straight-through cable for the connection. To verify the network connection, I will use simple PDU in the simulation mode. So now let's click the PC0 and the PC15. As we can see that the message is transmitted to the PC15. So now it will send back the message to PC0. Successful. It means that the implementation of the network is successful. So now I will conduct a ping connectivity test. I will ping from PC0 on the location A to PC15 at the location B. Zero percent loss, it means that the ping is successful. So now let's try another one from location B to A. Let's try to ping from PC 20, ping to PC 0. %, loss, it means that the pinging is successful. That's all. Thanks for watching.